So in today's lecture, I'll be trying to complete what? Friction, then what? Pseudo forces, and then dynamics of circular motion. Right. So before I do that, the most important topic of Newton's laws of motion is this free body diagram. Right. And as I have discussed earlier, in free body diagram, you need to what? You need to show free body diagram. Right. So first you do is that you dissect all the other blocks. So you dissect each blocks. So you separate each blocks, right? And then you do what? You count all the forces acting on a single block, right? And then you apply Newton's second law, right? Am I correct, everyone? Right, and that is what? Summation of all the forces should be mass into acceleration, right? So this is how you do the free body diagram. So how many common forces do you guys know? So one is obviously the weight, right? The second one is what? Tension. And there are what? Friction. And there are pseudo forces, but you need not to apply this. Right. So let me give you one example that how do you apply the free body diagram. So let's just say that you have two blocks, right? So this is mass 5 kg and there is one pulley, right? So one pulley here and so one pulley and it is attached with some rope and this one is what? Let's say 10 kg of block, right? So this is a frictionless pulley, right? So how many forces will act on this part and how many forces will act on this part, right? We have to dissect each block separately, right? So for this block, we have what? One is tension, right? Which is pulling this string in this direction, right? So tension you guys already know, right? Which acts on the strings, right?
Yes, sir.
And then there is weight. And so this mass is heavier and this mass is what? Lesser, right? So this will pull it what? Downwards and this will move upwards, right? So this will have acceleration like this and this will have acceleration like this, right? Downwards. So for this block, we will apply the FBD. Okay. So the 5 kg one block. So one is tension, right? The other one is the weight and the acceleration is what? So are there any more forces acting on this block? Any more forces, Iram? Anna, Tanya, any more forces acting on this block?
Air friction.
No, we assume that there is no friction in the air, right? So no friction in the air. Okay. So these are the all forces, right? So now what is left? We have to apply the Newton's law of motion, the second law, right? So summation of all the forces will be what? Mass into acceleration, right? So what are the forces? Tension and weight, right? So we write the sign of this tension and mg according to what? The direction of acceleration. So the direction of acceleration is upwards. So the tension will be positive, right? And this is against the direction of the motion. So this is mine, right? So this is first equation. Okay. And in these type of question, they mainly ask you about the. So in these type of question, they mainly ask you about the tension. So tension or acceleration, right? So this part is clear, right? And the other part will be what? The block of mass 10 kg, right? So, so what is the direction of the acceleration here? What is the direction of the acceleration, guys?
Downwards.
Downwards.
Yes, downward. Right. So be interactive, guys. Otherwise, this will be boring. Okay. So yes. So acceleration is downwards and weight is also downwards, right? And tension is upwards. So what will be the second law of
Mg
motion?
minus T equals to Ma.
Yes. So mg minus t equals to m, right? So this will be what? So we can calculate the value of t from here. So mg minus ma will be what? The tension, right? So this is the second equation. And if we put the value of t from here to here, so this will be what? So I should write the masses because otherwise this will get cancelled, right? So, so this is actually t minus this is 5g, right? And I wrote capital M here. So this is Mn and these are masses also, right? So, right. So this is what? 5a, right? And this is what? This is 10g minus 10a equals to t. Right, na?
Yes, sir.
So t is what? 10g minus of 10a minus of 5g equals to 5. Right. So this will be what? So this will be 5g and this will be what? 15g. Right. So a will be 5g by 15 and this will be 3. So a will be g by 3. Right. And tension will be what? So tension is 10g minus 10a. So this will be what? 10g minus of 10 into g by 3. Right. So this will be what? 30g minus of 10g by 3. So 20g by 3. Right. Any question up to this point?
No, sir.
Right. So this is how you apply the free body diagrams, right? And the forces that I want to talk about here is the frictional force first, right? So I already talked about this in the earlier classes. So as you know that there are two types of frictional forces, right? One is when the body is in static form, in rest, right? And the body, when the body starts to move, then the other kind of frictional forces acts on them, right? So let's say when the body is at the rest. So types of friction, right? One is the static friction, and sometimes it is also called the limiting friction, right? And the other one is the kinetic friction, right? So as the name suggests, static friction, when the body is the frictional force is that great that it makes the body to stop or not move forward, right? So it is denoted by FL or FS, right? And as you guys already know that this is directly proportional to what? The normal reaction, right? So this is equals to mu LM, right? Where your mu L or mu S is the frictional part, right? And when the body starts to move, okay, so let's say there is a block, right? There is a block and you apply a force, right? And it is not moving, which means that the friction that this surface is applying on this body, right? The Fs. So Fs is what? Greater than F, right? So this is making the body not to move, right? And when the force, this F is greater than Fs, then the body will start moving, right? So when the body starts moving, the other kind of friction force applies on it, and that is what? The kinetic friction. Okay, so again, this kinetic friction Fk is directly proportional to the normal reaction. Sorry, right? And so you guys already know that the normal reaction is acting perpendicularly on the surface of this block, right? So this acts perpendicularly on this surface, right? So this is the normal reaction, right? Now,
Yes, sir.
Yes, sir.
okay. So this Fk is mu k, right? Where your mu L is greater than mu k. Okay. So this was about the friction, and let's do some question based on this friction. Okay. So first one is the basic simple question, right? So we have to calculate force of limiting friction or static friction. And there is a block of 20 kg kept on this surface, right? And we have given the constant of friction, the static constant of friction mu L, or the limiting friction constant. And this is the kinetic frictional constant, right? So these questions are very simple, right? So let's just calculate the first. So first one will be what? Force of limiting friction will be what? Mu L N, right? Right now?
Yes, sir.
And on this block, so normal reaction is this, right? Which is balancing what? The weight, right? So for equilibrium, your N equals to what? Mg, right? So your mu L and N is what? Mg, right? So mu L is given 0.4 and M is given 20, right? And G we know 10. Let's say 10. So this will be what? This will be, this is 8 and this is 80. So 80 Newton, right? And force of kinetic friction will be what? This is not actually moving, but yes, so 60 Newton, right? So Arpita has already solved. Okay, so second one is right. So second one is what? Fk is mu k and so what? 0.3. So as Arpit has solved, so let's just say 60 Newton, right? And acceleration and static friction, if applied force is 20 Newton, right? So on this block, 20 Newton force is applied, right? This is N, this is mg, and we know that the static friction is what? 80 Newton. So Anna, will this block move or what?
It will not.
Yes, so it will not, so the acceleration will be 0, right? So let's do the fourth one, right? So for the fourth one, okay. So when the applied force is 100 Newton, so we have to always make CFPDs. These are very, 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 very important. So if we know this part, then all Newton's law of motion is very easy. So this part, vector and calculus, this is all about the 11th physics. Okay, so if you guys are prepared with this, then this is it, right? The mechanics or the other part in 11th class. Okay, so this is what? 100 Newton. This is 80 Newton, right? This is N and this is what? So the body will move, right? Right? So if this is 80 Newton and this is 100 Newton, then which means that the body will move. And we have to calculate the acceleration, right? So we will apply what? We have already made this free body diagram. So we have to calculate the acceleration, right? We have to just write the Newton's second law for this horizontal component. Okay, so 80 acceleration ma will be equals to what? 100 minus 80, right? So this is 20 and mass is 20 and a, so a is what? 1 meter per second square, right? Any doubt? This was a very simple question. Now just let's make it a little bit complicated. Try. So now this block is on an inclined plane, right? So this block is on an inclined plane and this is what? Sliding, right? So if this is sliding and this is the frictional forces is acting upon them, right? So we have to calculate first the force of limiting friction, right? So force of limiting friction, and then we have to calculate the force of kinetic friction, and then we have to calculate. So the first part, and that is what? DFPT. That is most important, right? So this angle is given 37 degrees, right? So what will be this angle? So let's just say that this comes here, right? So let's see this diagram. So this triangle. Actually, I made right. So this diagram, this angle is what? This angle is 90, right? And this angle is 37, right? So what will be this angle? -90 minus 37, right? Right, now?
Yes, sir.
Now this is 90 minus 37. So let me make a diagram. Okay. Let's just say this is theta here for the time being. Okay. So let's just say this is theta here. Okay. And this is 90 minus theta. Okay. So now just look at this triangle now. This triangle now. Okay. So this angle is 90 minus theta. This is 90. So how much will be this angle? I already I already wrote the answer. Right. So this will be what? Theta. Right.
Yes, sir.
So this is how this angle is. This angle is theta. Right. So when you draw the free body diagram, let me make the diagram again. So this was this, right? And right, so this angle is what? Theta. And the acceleration is like this. Okay. And this is what? This is what? The weight. Right. This is mg. Okay. So this is mg and the angle is theta. So recall the vector part. The two components will be there. So this part is what?
mg cos
Part,
theta.
right, mg cos theta. And this part is what?
G sin theta.
Right, mg sin theta. Okay. And on this block, the perpendicular force will be what? The normal reaction. Right. And friction will be where? So this is the frictional force. Right. Right now. So let's just make this diagram like this. Okay. So one force is acting like this, which is mg sin theta. Right. The friction is acting like this, which is F. Okay. And one force is acting like this, which is the normal reaction. And this is mg cos theta. Right. And the acceleration is where? So this is the acceleration. Right. Any doubt, any question?
No, sir.
Right. So let's just solve this problem. So force of limiting friction. This will be what? let's just apply here the so let's just apply the Newton's laws of motion, second law. But before that, we know that limiting friction will be what? Mu L N, right? And we know that N is what? Mg cos theta, right? N is mg cos theta. So this will be ml mg cos theta, right? So mu L is given 0.4 and m is given what? 10 kg, g is 10 and cos theta is what? So this was in the question 37 degree, right? And you guys remember what I said about this 37 degree part in right angle triangle? Do you guys recall? So you had so this was what? Let's say this was 3, this was 4, this was 5. So this was 37, right? Opposite to 3 was 37 and opposite to 4 was what? 53. So now cos 37 will be what? B by H, right? And sine 37 will be what? 3 by 5. Do you guys remember?
Yes, sir.
Right. So, yes, so cos theta is what? 4 by 5. Right. So 2 cancel and this will be what? 4 and this is 8. 8 4 are 30. So 32. Right. And what will be the kinetic friction? So this part is same, this much. Yes, so who has given me the answer? 16, right. So Arpit is one step ahead of me. I do first question, Arpit does the second question, right? So nice, Arpit. Okay. So yes, so 0.3 and this was what? This was 80, right? Huh? What?
I took mu k as 0.2, sir. It's in the question.
So it was 0.2. Sorry. Yes, 0.
Yes, sir, it's 0.2.
Right. I'm sorry. Right. So this is 60. Yes. So 0.2. So this is 16. Right. And now we have to calculate the acceleration. Right. So for acceleration, we have to apply the Newton's second law of motion. Right. So for this FBD, for this part, we have the second law as what? So we have F, we have mg sine theta, right? And we have ma, right? So what will be the sign of mg sine theta? This is positive and this is negative, right? So let's just try it like this. Mg sine theta minus F is what? Is ma, right? Okay, and we already know that this block is moving, so kinetic friction will be there, right? So F FG, right? So mg, we have to calculate acceleration, and so we already calculated this part, right? So this came out to be what? 16 Newton. So mg sine theta minus 16 is what? 10 into 8, right? So mg, this is what? 10, and this is 3 by 5, right? So 2 minus 16 is equals to 10A. And this will be what? So this will be what? 60 minus 16 is equals to 10A. So this will be what? 44. Right. 10A. So A is 4.4 meter per second square. Right. So any doubt? Any question up to this point?
No, sir.
No, sir.
So only Marita and Arpit is responding and others are silent. Why? Are there any problem? Iram, Sanya, Samara, and what? Anna. Did Heather join? Abhinav. Any question?
No, sir.
No, sir.
Now, okay. Okay. So now you all responded in sync, right? Okay. So yes. So this was about the friction for on an inclined plane and friction for a moving body on a straight path, right? So the next topic is the pseudo forces, right? So for pseudo forces, first we have to know about the frame of reference, right? So frame of references. So on the basis of the motion of the frames, right? So there are two kinds of frame of references. One is the inertial frame, right? And the other one is the non-inertial frame. Uh, Right. So what is an inertial frame? The frame which is not accelerating. Meaning it is either at rest or in uniform motion, right? With respect to Earth. Okay. And what is a non-inertial frame? So this is an accelerating frame. Right. So what are the examples of so non-accelerating frame meaning if whether this will be rotating, right, or accelerating, right? So what are the examples of the inertial frames? So let's just say that a car is moving with a constant speed. A car is moving with a constant speed. Right. Or you say that a pole or whatever, which is at rest. A pole is at rest. Right. And what are the examples of the non-inertial frames? So let's say the rotating fan. Okay. And the second one is the merry-go-round. So did you guys ever hopped on this merry-go-round, which is in the park, right?
Yes, sir.
So,
Yes, sir.
so you always feel that someone is pushing you outwards, right? But there are no actual forces right there, right? But you feel that somebody is pushing you away from that merry-go-round, right? So let's just say that you are sitting in this merry-go-round, right? My drawing is very bad, and this is moving. So you feel that you are pushed away like this, right?
Yes, sir.
So these are the non-inertial frames, the example of non-inertial frames, right? So the property of this inertial frame is what? That all the Newton's laws of motion are valid, right? And in the non-inertial frame, Newton's laws are invalid. Laws of motion are invalid, right? And that is why we need pseudo forces to explain to explain the physics behind it, right? Okay, so this was about the pseudo forces. So what are the pseudo forces? So these are virtual forces which acts in a non-inertial flow, right? Right. So one example, as I've already told you, is the merry-go-round, right? And the other example could be when you are in lift. So the most common example, right? So when you are in a lift, right? And when somebody is watching you from the stairs or from the ground, right? So somebody is watching you and the lift is moving and this is made of glass and somebody is standing there, right? So for this person, you see that the lift is moving, right? But when you are in the lift, so this person will not feel any motion, right? When he is disconnected from the outside world. So he will not feel any motion. So for this person, the lift is accelerating. But for this person, the lift is not accelerating, right? So for this person, the free body diagram will be what? So this is mg, right? This is normal reaction and this is acceleration for this person, for the frame of reference of this person, right? So Newton's laws of motion will be what? So MA will be what? N minus mg, right? So this will be the, and your N will be what? MA plus mg, right? So this will be the normal reaction for this person, right? But for this person, this person will feel only what? That there is a weight, right? And there is a normal reaction. So he will feel that your normal reaction is equals to mg. But this is wrong, right? Right, na?
Yes, sir.
Yes, sir.
So that is why Newton's laws of motion are not valid, and we have to assume some pseudo forces, right? So we have to assume the forces which are for this person, the force pseudo is acting downwards, right? So F pseudo, right? So then what will be the second law of motion? So the second law of motion will be what?
M into 0.
No, yes. So this is what? F pseudo, right? And this is N, and this is N, right? So your N will be what? Mg plus F pseudo, right? And what did you say, Anna or Idam? What did you say?
So I was saying that the net acceleration in non-inertial frame will be 0. So
Right.
m into
Oh,
0.
right. So yes, so these are for non-inertial frame, these are in equilibrium, right? So the net force is 0, right? So this this is equals to the sum of these, right? Right, Manita.
Yes, sir.
So now when you compare this with this, sorry, so this one is this, so this should be this, right? So your pseudo force is actually what? So your F pseudo is mass into acceleration, right? This acceleration or this mass is the frame of mass of the frame of reference. So clear this part. Any doubts up to this point?
No, sir.
Right. So the next topic is what? The dynamics of circular motion. Okay. So as you have already studied or recall that they are what? They are analogous physical quantities which are analogous to linear and angular motion, right? So in linear motion and in angular motion, this you already learned. So your displacement was x, and in here your angular displacement was what? Theta. Here your velocity was v, and your angular velocity was what? Omega, right? So this was dx by dt, and this was d theta by d, right? And this linear velocity was related with omega, like v was omega, right? And then you have acceleration, which was a, and here your angular acceleration was what? Alpha. And this was what? Again, this was d omega by dt, right? And your this linear acceleration was related with, so again this acceleration was related with what? Alpha r, right? So this was about the correlation between the linear motion and the angular motion, right? And we also learned about what? The centripetal forces. Centripetal force, right? So in circular motion, we learned about the centripetal force. So when you move in the circular path in circular motion, so the tangents show the velocity, linear velocity, right? So this is the linear velocity. And towards the center, radially you feel a force, right? So that force was what? The angular, the centripetal force. Right, this we did. Right now.
Yes, sir.
Now let's just do some question based on this centripetal force. Okay, so Who has just joined?
Sir, it was me.
Okay,
I
so you
lost
got
my back in between.
connection. So you got up to which point you were with us? So did you miss any part?
Sir, you were doing that the first question or the second question.
Okay.
Mm,
Okay, so that was a while ago, 15 minutes or so, right? So now, as I was just revising the circular motion, right? So you already know about the centripetal force, right? So this is a question based on the centripetal force. Okay, so a ball of mass 0.1 kg is suspended by a string, right? 30 centimeter long, and keeping the string always tight, the ball describes a horizontal circle of radius 15 centimeter, right? Calculate the angles too. So there is a ball, right? And this is suspended with some string, and this is making a circle here, right? So this is moving like this, right? And we have to calculate. So a ball is by string, keeping the string always tight. The ball describes a horizontal circle of radius 15 centimeters. So radius is given, right? So this is 15 centimeter, and this is theta, right? This is theta, okay? And this is the mass, okay? And this is the string. So again, what is the approach, right? First thing is that we have to make the FPD of this part of the mass, right? So over here, what are the forces acting on?
Weight.
Yes, so the first one is weight, right? And
Tension.
yes, so this is tension, right? And this is making some angle. So this is what? 90 minus theta. So this will be what? Theta, right? Right
Yes.
now? And this part, so this is moving in the circular motion, right? So this is moving in the circular motion. So towards the center, there is a force, right? So towards the center, there is the centripetal force, right? Are there any forces? No, na? Right. So for this part, you have a tension, right? And this is making some angle theta, right? You have this centripetal force, and you have mg, right? So only three forces acting on this. So again, tension is acting with some angle, right? So this will have some components, right? So this will have what?
T cos theta.
Yes, so this is t cos theta, right? And this is t sin theta. Okay, so did I? Yes, so tension, and this is right. Okay, so this t sin theta will be equal to what? To balance this centripetal force, so t sin theta will be what? Your FC, right? And t cos theta will be what? Mg, right? Any doubt?
No, sir.
So FC is what?
M omega square.
Right. And your T cos theta is what? Mg, right. So I always write the small m. So this is mg. Right. So we will divide this part. Right. So this will be what? Dividing this one. So we'll get what? Tan theta is m omega square. So R by mg, right? So this will be cancelled, right? So this will be what? Tan theta into g by r is omega square, right? So we have to calculate the angular speed, right? So this is the angular speed, right? So this will be what? Root over tan theta g by r. Right, any doubt up to this point? Any
No,
question?
sir.
And we can calculate tan theta from here, right? So tan theta was what? So this is theta, right? And this is what? R, okay. And this is what? Length. So tan theta will be what? P, which is R by B, right? So this is L, this is R, so this will be what? L square minus R square, right? Right,
Yes,
na?
sir.
Okay, so where yes. So we have to put the value of tan theta here. Right. So tan theta is what? R by root L square minus R square into G by R, right? So this will be what? Root G minus upon L by R square. So this is omega. Right, so this is the answer. Okay. Any question? Any question up to this point?
No, sir.
Now, in the same question, they are asking about what? So in the same question, this is the same question like before, right? And in here, a particle of mass m, 21 gram, attached to a string of 73 centimeter length, is whirled round in a horizontal circle, right? And if the period of revolution is 2 seconds, find the tension in the ring, right? So this time we have to find, so the period of revolution is given, right? So T, which is what? 2 pi by omega, right? So this is given 2 seconds. And we have to find the tension. Okay, so this let's say this is T. And we have to find the tension. Right. So the diagram will be same. Okay, so this is the tension, right? This is the block, this is mg, right? So this is theta, right? So this will be theta, right? So this is again t cos theta, and we have t sin theta, right? And then your centripetal acceleration is acting, right? So we have to calculate what? T sin theta is your m omega square r, right? And t cos theta is what? Mg. Right, so these are the two equations. Right. Am I right, everyone?
Yes, sir.
Okay, now we have to calculate this part, t part, right? So we can't divide this. Okay, so let's just take this part. So from here, t sin theta is m omega square and r, right? So r is what? This is your r. This is L, right? And this is theta, right? So this is this, let's say that we have to calculate r, right? So we have given this r and this is L, so we can, yes, 11470 pi square, and this is the answer for which question?
So the tension.
For the tension. Okay, so let's just calculate. And do we get the right answer or not? So let's just calculate from there. So this is B, right? And this is H. So cos theta. Cos theta is what? R by L. So your R is what? L cos theta is R. Right. So we can put the value here. So m omega square and R is what? L cos theta. Right. So T sin theta will be what? T will be m omega square L cos theta by sin theta, right? And what do we know? We know that right. So we calculated omega. So we calculated omega, and which was what? Tan theta into G by R. So we calculated. So this is what? So m and omega square was tan theta into G by R, and this is what? L, and this is what? Tan theta. Right. So tan theta cancels, and we are left with what? MGL by R. Right. And okay, so omega square, right? So omega is 2 pi by T, right? And omega square will be what? 2 pi 2 pi square and t square, right? So this will be what? T square by 4 pi square. So we should have written the value of it. So let me write this part. So m omega square and L cos theta by tan. Right. So this will be what? M and 4 pi square. Omega square is what? 4 pi square. And R, and then tan theta is what? Let's say tan theta into t square. Right. So what did you get, Marita? 1470, something like that. 1417 and pi square. Did you get this answer?
Yes, sir.
So let's just calculate from here. So 2
I just
seconds.
substituted for sine theta and R got cancelled. So
Okay. So mass is 21 gram and length is 70. Right. So mass is what? 21 gram. Length is what? 70. And t is what? 2 seconds, and then what? So yes. So mass is 21 gram. And did anybody else get the same answer? Anybody else got the answer? So tan theta was what? Tan theta. Okay, so I should have calculated from what happened. R is not given.
no, sir.
And so yes. Yes, so where R is not given, then T cos theta is mg. Sorry, let me. This. So this was the equation, right? And I substituted L cos theta, right? And omega I know. This is this. And R is, so my tan theta is not cancelling, right? Tan theta will be, so my tan theta will be R by root over L minus R square. So there should be R, value of R, right? Did I miss R?
Sir, if we try substituting for sine theta in this third equation, R gets cancelled.
R gets cancelled. Which was the third equation?
So T sine theta is equal to m omega square into R.
right? And when you put sine theta, okay. So when you put the value of sine theta, so sine theta is what? Sine theta is P by H, right? R by L. So from here, your R is getting cancelled, right? Right. Okay. So yes. Yes. So from here, so T sine theta is M omega square R, and T is M omega square R by sine theta, right? And this is 4 pi square by T square, and R is what? Your sine theta was R by L, right? So this was R, and this was L, and this was R. So this was getting cancelled. So this was directly, okay, so 21 and then 4 pi square, and then L was 70 into 10 to the power minus 2, and then T was 0.2. Right, so directly we could have get this answer. Okay, so this is what? 84 into 70 into pi square, and this is minus 2, and this is what? 0.2. So let's say 2 into 10 to the power minus 2. Right, so this cancels. And this is 35, right? So 84 into 35 is what? So what? I'm not getting.
Sir, within square too.
Oh, yes. So there is 4, right? So 4, and this is what? 2. So this is 4, 2, right? So this is what? 42, 35, 70, and this is what? And this is, right. So, okay. What is happening? So this is 6. I'm getting this. And you got what? 1470. So this is the right answer, right? Or did I do any mistake? So did anyone else solve this problem? Arpit?
Sir, I guess it's 1470.
So you got also 1470.
It's, the final
Okay.
answer. Yeah.
Okay, so where did I do wrong? 4, 4 2s are 8, so this is 84, right? And then
Sir, in the
then,
multiplication part, sir, rest is the same, sir. 42
Huh?
into 35. Sir, it is 1470.
42 into 35.
Sir, rest is correct, sir. The calculation part only.
Okay, so let's say that this is the right answer. Okay, and let's just move ahead because we have 15 minutes. So we already spent what? 15 minutes on this question. Right, so let's move ahead. And so these are the concepts that I was going to talk about in this today's lecture, right? So anybody has any doubt in circular motion or friction and pseudo forces? So any doubt? Hiram, Anna, any doubt? Sanya, Samaira?
No, sir.
Right. So let's just do this question. Right. So two bodies of mass 4 kg, 6 kgs are tied to the ends of a massless string. The string passes over a pulley which is frictionless. The acceleration of the system in terms of acceleration due to gravity is right. So two masses and the pulleys are attached. Right, this problem we did. So this is 6 kg, right? So we have to write two FBTs for two blocks. So the acceleration, this is tension, and this is heavier. So this here is acceleration, and here is tension and acceleration, right? So for 4 kg, we have tension, and we have acceleration, and we have weight, right? So what will be the Newton's law? MA will be what?
Force.
Yes.
mg minus
T
t.
minus
Yes, T minus mg,
Sorry, T.
right? T minus mg, so we can calculate the value of T from here. So T mg plus m. Right, so this is G plus A and M is 4, so 4G plus A. Right, and for the second part, we have what? For the 6 kg block. We have tension upwards, acceleration downwards, and weight downwards. Right. So what will be the second law?
mg minus T is equal to m.
Right. And we can put the value of T from here. So this is what? So this is 6T. Right. So who got the answer? G by 5. Okay. So let me check that. So 6G minus 4G minus 4A equals to what? 6A. So this is what? 6G minus 4G is 2G. Right, and this goes here. So 6, 4, 10A. So this is 5. So G by 5. So this is the right answer. Right, G by 5. Right answer. And who got the answer? Anybody else? Mahita, did you solve this time? Hiram.
Yes, sir, I had sent.
Okay, so Sani also did the problem. Right. So nice. Okay, so let's just do this problem. Okay, so this is the second problem. And a block of mass m is placed on a smooth inclined wedge ABC of inclination theta as shown in the figure. The wedge is given an acceleration a towards right. So the wedge is given, so this wedge is given an acceleration. The relation between a and theta for the block to remain stationary, right? So we are looking with respect to this block. Okay. So for this block, what frame we need to use? So these are moving, right? So let me make the diagram. So this wedge is moving like this, right? And there is some mass, okay? And this is the theta, right? So we have to apply the non-inertial frame. Right. And if the wedge is moving like this, so for this to be in equilibrium, right, this block will experience a force in this direction. So MA this direction, right? And you have MG in this direction, right? And you have a normal reaction in this direction, right? So we have to calculate what? So this normal reaction will balance this force, right? So this is theta, right? So this will be what? So this will be theta, right? And this will be theta, right? So this is theta, right? So who got the answer? So this is what? N sine theta, and this is what? N cos theta, right? So for equilibrium, for this body to experience no acceleration or no force, right? So this will be N cos theta will be M, right? And your MA will be what? N sine theta, right? So mg is equals to N cos theta, and we will divide this part. So this will be what? A by G is N cancel tan theta, and this is G tan, right? So any doubt for this question? Any doubt, guys?
No, sir.
Right. So this is the right answer. Okay. Now this question is very important, and they ask it so many times. So this one is important. Right. This is your homework, right? So please do this problem. So this is your homework, right? And this problem I will do. Okay. So please note down this question, right? And please do the homework. Okay. So the next question. A person of mass 60 kg is inside a lift of mass 940 kilograms, right? And presses the button on control panel. The lift starts moving upwards with an acceleration 1 meter per second square. If G is 10 meter per second square, the tension in the supporting cable. So Arpit, who is watching the lift? So are we referring to the person inside the lift or the person outside the lift? So are we in the inertial frame or the non-inertial frame? Arpit, in this question, what frame of reference we should choose? They are not talking about the person which is inside the lift, right? So we should choose what? Yes. No. We have to choose. So they are not asking about the person inside the lift, right? So we are not calculating from the inside. We are calculating the tension from the outside. So whenever they are talking about the tension, which means that we are seeing from the outer part of the lift, from the outside. So they are talking about the inertial frame. right? So what will be the corresponding free body diagram? So the acceleration is upwards, right? And right, so option B. Okay. Option B, let me check. Okay, so right, tension and then mg. Right. So what will be the Newton's law? Newton's law will be what? Hiram?
mg minus
Yes, mg, t, it should be t minus mg, right?
sorry.
Yes, so t, they are asking, and what is the overall weight, overall mass? So this is 60 and this is 940. So total mass will be what? 1000. Yes, 1000, right? So this is 1000 g and this is 1000 and a is given. A is 1 meter per second square. Right, and g is 10 meter per second square. So this is 1 meter per second square. So t will be what? 1000 into 10 plus 1000. So right, so 10,000 plus 1,000, so 11,000 Newton. So Marita got the right answer. Right, so Arpit, Hiram, did you get the same answer? Anna, are you solving? So Samaira, Anna, all are there. Hiram, or did Hiram left?
So,
Okay, so you are there. Sorry. Sorry. So did you solve this?
yes, sir.
Okay.
Solve it. Sir.
Okay. So, and this problem is same, right? So these two problems are somewhat similar. What is that? Yes. So please write it as your homework. This 38 and 39. Right. And what is, okay, so this I will do. Right. So in this question, a body of mass m is kept on a rough horizontal surface, coefficient of friction is b, right? And horizontal force is applied on the body. So let's say something is kept right here, right? And a horizontal force is acting. Right. And friction is acting in this side. Right. So, but it does not move. So this is the limiting friction, right? The resultant of normal reaction and the frictional force acting on the object is F, right? So resultant of this frictional force and the normal reaction. Right, so this is the normal. And what will be the resultant? So this will be the resultant. Right, so this is F. Right, and where F is what? So they are asking about F. Right. So you guys know that N is what? Mg. Right. And the resultant of these perpendicular forces. So what is from the vector analysis? Your resultant is what? A square plus B square plus 2AB cos theta. So option C, Marita, right. Option C, so let's just, right. So cos theta is what? The angle between the vectors are what? Hiram, Anna, the angle between vectors are? Arpit, the angle between the vectors are 90°, right? So this is 0. So a square plus b square on. So this is what? FL square plus n square, right? So let's just calculate the FU. So this is FL square plus n square. And your FL is what? Mu L, or this is mu here. So mu and n square and n square, right? So n square is outside, and this is what? Mu square plus 1. And n is mg, 1 plus mu square. So F should be what? For this to be what? It does not move, right? It does not move, which meaning that F is less than or equals to . So Marita got the right answer. This one. Right. So we'll stop at here, and in the next class, I will do this problem, right? I will do this problem, and then I will talk about bending of rods and then vertical motions. Right. So these two parts are remaining in your Newton's laws of motion. Right. So in the next class, I will be covering these two. And then I will start work energy power. Right. So that is how your syllabus sheet is given. Right. So we are going according to our syllabus. Okay. So does anyone have any doubt? Any question?
No, sir.
So, okay. So if you don't have any question, then you guys can leave, or if somebody has any doubt, then they can ask. Right, so I'm stopping here. Okay, so guys, let's meet tomorrow, and then we will start from here, where we stop. Right, bye everyone.
Bye,
Thank
sir.
you, sir.
Thank you, sir.
Bye.
Thank you.